calculate voltage across minus J2. This is minus J2 ohm. This is minus J2. इसके across हमें voltage find out करना है, impedance, and verify the reciprocity theorem for the network shown below. Previously कैसा था? What we have in the last example, the given thing is the voltage, and we are calculating the current. In this case, the things are different. Given thing is the current, and we are calculating the voltage across this. Is it right? Look at how will be the terminology in this case. The terminology will be something like that. First, we will find out the voltage across this. How we will calculate the voltage? This is one branch and this is second branch. We can calculate current in this branch by using the current division rule, and then that current into this impedance will be give the voltage for the case 1. In case 2, what we will do? We will apply the current source here. This current source here. And we will calculate the voltage across this terminal. Voltage across terminal, and we will verify both. The ratio of the voltage V in the first mesh to the current I in the second mesh is the same when the positions of V and I are interchanged. Is it right? Now case 1. In the case 1, first we will find out the voltage across this. Here no reduction is required because circuit is that much simple. If we know the total current, this is one branch and this is another branch. For this branch, I will assume its current as I1. For this branch, I will assume its current as I2. This is I2. We are interested in this voltage, that's why we are trying to find out its I2, which is current I2. Is it right? In this case, I will directly find out the value of the current I2 here. Now, calculating current I2. Current I2 using current division rule. Current division rule. How is the current I2? This I2 is equal to, how is the case? Total current. Total current is phi angle 90 degree. This is very same as plus J5. J5. अगर हम इसको convert करते हैं, if I am converting this value to the rectangular form, in that particular case, it will be plus J5, because whenever angle is plus 90, it will be plus J5. Angle is minus 90, it will be minus J5 in that case. Otherwise, you can use the calculator and you can convert that value. Now, how is the total current? Total current is J5 into impedance of the opposite branch. In this branch, we are interested in the current, that's why this is the opposite branch. That is 5 plus J5. Divided by impedance of both branches, that is 5 plus J5. This is one branch, and the second branch is 2 minus J2 is the second branch, that is plus here. Here should be the plus. I will repeat the formula. In this branch we know the current, that's why no need to bother about this branch. How is the current in this particular branch? In this particular branch the current is J5. This is the given current, which is J5. I will use the current division rule for these two parallel branches. If we are interested in the calculation of current in this particular branch, then I will use the current division rule, which is nothing but total current into impedance of this opposite branch divided by impedance of both branches. Otherwise, in place of showing this direction, something like this, this may be the current I1, something like that, to avoid the confusing part. Is it right? Now here, if I am working on this calculation, which is equal to, how is the numerator? In this case, I will find out the calculation of the numerator. Now look at the calculation of the numerator. J5, this is 5i, this is 5i, I will close the bracket, into, this is into start bracket, 5 plus J5. 5 plus 5i, I will close the bracket, which is equal to, its real part is minus 25. Its real part is minus 25. Then shift time is equal to, if I am using that, its imaginary part is also minus plus J25. It is plus J25 is that part. Is it right? Here, in this case, I will work on the denominator. Otherwise, I will check the calculation. I have some doubt. That's why I will check the calculation once again. That is 5i into start bracket. That is 5 plus 5i. 5 plus 5. I will close the bracket, is equal to, this is real part is minus 25 and imaginary part is minus J25. Sorry, Imaginary part is shift and is equal to minus j25i. Absolutely fine. Then I will work out on the denominator. If we are working on the denominator, 5 plus j5, this is 5 plus 5i, I will close the bracket, plus start bracket, 2 minus j2, 2 minus 2i, I will close the bracket, which is equal to, that is the 7. 7 is the real part, and shift and is equal to, then imaginary part is plus j3. Plus j3 is that part. Is it right? Which is equal to, I will find out this division. If we are finding this division, in that case, I will use the start bracket here, start bracket. This is minus 25 plus 25i, close bracket, divided by start bracket, 7 plus 3i, I will use a close bracket, is equal to, that will give minus 1.72. This is minus 1.72 is the real part, and I am using the shift and is equal to, then it is plus j, this is plus j, 4.31. 4.31, this is amperes, is the current. Is it right? If we know this current I2, we will find out its voltage V2. What is the formula for voltage V2? This voltage V2 is equal to this current, that is minus 1.72 plus j, this is 4.31 current, into its impedance, and the impedance is minus j2, means we are able to find out its voltage V2 in this case. Is it right? We are able to find out its voltage V2. How is the formula? Just I will work out this calculation. Minus 1.72 is that part, plus 4.31 I will close bracket, into, this is minus 2i, I will close the bracket, is equal to, this is 8.62. This is 8.62 is the value of V2, that is the real part, and shift tank is equal to, if I am using, then it is plus j, 3.44. This is 3.44 volt is the value of the voltage V2. Is it right? This is the value of the voltage V2. What was the first problem, or first part of the problem? Calculate voltage across minus j2 ohm impedance. This is minus j2 ohm impedance, its voltage is this. Now, if we want to verify this theorem, this current is the same. If we will change the positions of V and I, in that case, if we will find out this value of the voltage V1, which is same as this, in that case, we can say that this theorem is verified. I will start the case 2. This is case 2. How is the case 2? In the case 2, we will bring this current source here, and we will calculate voltage across this point. This here figure will be something like this for that calculation. This will be the figure. Here will be the one resistance. Here is the capacitor, and we will connect the current source here. We will connect the current source here. How is the direction? Upward. What is its value? Plus j5 amperes. Because that is 5 angle 90 means plus j5. And we will find out voltage across this point. Here this value is 5 plus j5 ohm. This impedance. Here it is 2 ohm. This is minus j2 ohm. Is this impedance? And we are interested in the calculation of this voltage. This voltage. I will name this voltage as V2 dash. Is it right? Kuch naam dena hai. You can give the V1 also. But here I have taken V2. That's why I am giving here name as a V2 dash. Now look at how will be the what will be the current in this branch. Current in this branch. Because this network can be drawn something like this. The same network can be drawn something like this. I will draw here for the simplicity. Otherwise, no need of this figure. Is figure ka zarurat nahi hai. Even then, I will draw this particular figure. इसी figure को अगर मैं draw करता हूँ simplified way में, it will be something like this. It will be something like this. This value is minus j2. This value is the current, which is plus j5. And this complete branch is nothing but 2 plus 5, that is 7. Is 7 plus J5. This is 7 plus J5 is the impedance of this, because ये इसके series में है. ये इसके series में है, because this is one circuit. If for time being, if I am assuming this part is not there, ये part नहीं है. If time being I am assuming this part is not there, in that case these two impedances are in series. तो इसका series combination कितना हुआ? This value. Is it right? Now we are interested in the current in this complete branch. Current एक resistance में नहीं होता है. Current is always in the complete branch. If I am using the current division rule and I am calculating the current in this complete branch, in that case, how will be the current? I will name those values and then we will calculate the current. In this branch, I will name this current as I2 dash, and in this branch, I will name that current which is as I1 dash, and we will find out the I1 dash. How is the formula for I1 dash? Total current. Total current is J5 into impedance of opposite branch. इस branch में calculate करना है. Means indirectly in this branch we are interested in the calculation of the current. Is it right? Total current into impedance of opposite branch. That's why minus J2 will be the opposite branch divided by impedance of both branches. इस branch का impedance मैंने यहाँ पे find out किया है, which is 7 plus J5 plus this is minus J2. This is minus J2 is the second impedance. Are you getting me? This total current into impedance of opposite branch, which is minus J2, divided by impedance of this branch and impedance of this branch. This branch का impedance minus J2 plus this impedance. I will work out on this calculation how will be the numerator and how will be the denominator, and then we will find out its value of the voltage. If I am working on this calculation, numerator, in this case start bracket, 5i, this is 5i close bracket into start bracket, minus 2i, I will close bracket, is equal to, its real part is a 10. Its real part is a 10 and shift time is equal to, its imaginary part will be plus 0i or I0 or J0 is the real part. Because look at the calculation, j into j is j square. We can do the oral calculations also. J into j is j square, which is minus 1, and this minus will become plus, and 5 to the 10, and that value will be here. Divided by denominator. How is the denominator? 7 plus j5. 7 plus 5i, I will close the bracket, plus start bracket. This is minus j2. Minus 2i, I will close the bracket, which is equal to, this value will be, the 7 is the real part, and shift and is equal to, the imaginary part will be plus j3. This is the value of the denominator. If we will calculate its current, in this case by doing that division, how will be the division? Start bracket 10, I will close the bracket, divided by start bracket, 7 plus j3. This is 7 plus 3i. I will close the bracket, is equal to sign. In this case, its value will be 1.20. 1.20 is the value, real part, and shift time is equal to, if I am using that, then it is minus j 0.51 or 57 is 52. I will take this amperes is the current I1 dash. ये current I1 dash है. Now, in this case, we have calculated V2 here. I will try to find out V2 dash. In this case, we will find out the V2 dash. How is the V2 dash? Its current into its impedance. Its current is 1.20 minus J, it is 0.52 is the current into its impedance, and its impedance will be 5 plus J5. This is 5 plus J5, which is equal to, work out this calculation. If I am working on this calculation, start bracket, it is 1.2 minus 0.52i, I will close the bracket, into this value 5 plus J5. 5 plus 5i, I will close the bracket, which is equal to, this is 8.6. This is 8.6. 8.6 is the real part of this calculation, and shift end is equal to, that is plus J 3.4 I. 3.4 is the value of this voltage, which is V2 dash. Now here in this case, to verify this theorem, look at this part. Look at this part, V2 dash. this voltage and look at this V2, this voltage. Both voltages are approximately same. The errors are in the calculation may be due to the rounding error. Is it right? And if we are verifying, means in this case, if we are finding V2 upon this I, it should be same as V2 dash. This is V2 dash upon I, because in this case V2 is the same. This V2 is the same and I is also same. In this case I is a 5 angle 90. In this case I is again 5 angle 90, which is plus J5. Means here, therefore we verified this theorem. Therefore we verified reciprocity theorem.